Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are doing a topic video on partial fractions. This is a crucial component in your integration chapter, and that's why it is vital that you understand this topic to move on to advance your integration chapter. So this might be familiar to some of you. You would have learned this in year 11 special 1-2, but of course that was a year ago. I don't expect everyone to remember what they've learned a year back, so I'm going to start off fresh. And of course, if you haven't learned partial fraction, make sure you check out this video, watch this video first before you go do your exercise. Right, so first of all, what is partial fraction? Partial fraction is essentially splitting one fraction into multiple fractions. So usually in this course though, you'll get 2. Sometimes you get 3, but that's pretty much it. That's the max. How does partial fraction work? Here's a great example. Previously, in your maths, when you're doing fractions, adding them up together, 1 plus 3 maybe plus 1 over 4, what does that do? Well, you combine the fraction together, right? You make them have the same common denominator as 12 in this case, and then of course 3, if you want to have the 3 become a 12, you multiply by 4. So you multiply 4 on both numerator and denominator. And then for the 4, you multiply by 3, and then you get 4 plus 3 divided by 12. So that is 7 on 12. What we're doing today is we're converting it backwards. So we're turning the 7 on 12 into 1 on 3 plus 1 on 4. So partial fraction. You're turning one fraction into partial fraction, okay? So that's what we're doing today, but not with numbers, with functions. There are 3 types of partial fractions. There is the distinct linear factors, there are the repeated linear factors, and then there's the irreducible quadratic factor. I'll segment this video into 3 sections. We'll start off with linear, move on to repeated, and then to the last one, irreducible. So let's get into the first one, distinct linear factors. Okay, so what is the criteria for something to be in this category? That would be you have 2 or more linear factors on the denominator, and then on the top is just anything. It can be a number, can be a constant, can be functions such as these. Okay, so if you have 2 linear factors or more on your denominator, that is a case of distinct linear factor. How would you partial fraction that? Well, the formula is you want to convert it into a over x minus 1 plus b over x plus 2. So that's an example. We wanted to convert it into this case, okay? A over x minus 1 plus b over x plus 2. And then of course, if I was to combine the fractions together, I should get back to my original, which in this case is 5x plus 1. Right, if you want to do partial fraction, there is the long way, the traditional way, and in that case we multiply a by x plus 2 and we multiply b by x minus 1. So why do we multiply? It's just the same thing as what I did here, right? If you want to make 3 turn into a 12, you have to multiply 3 by 4, but then at the same time you have to multiply the numerator by the same, which is 4, right? So what I'm doing is the same thing here. I'm multiplying the numerator by what I'm missing. So what am I missing on the denominator? I have under a x minus 1. I want the x plus 2 to be under a as well. So to do that, I multiply both numerator and denominator by x plus 2. And if you do that, you'll get x minus 1 times x plus 2, which of course is what we have here, x minus 1, x plus 2. You do the same thing for b. So what is b missing? b is missing x minus 1, right? See, I need that x minus 1, so I multiply b by x minus 1. And of course, on the numerator, we get 5x plus 1. We're trying to find a and b. To do this, we are going to equate coefficients. So ignore the denominators. Just ignore this. They are the same thing. Just ignore them. Just look at the numerator. So to do this, we expand the numerator, expand the bracket, ax plus 2a plus bx minus b equals to 5x plus 1. Okay, now we group them together, ax and bx. If you add them, so we're adding the coefficient, if you add a and b together, they should equals to 5x, right? So what happens here is a plus b must equals to 5 if you add them, so that you get the 5x. Same thing on the 2a and the minus b. If you subtract them, 2a minus b, that should equals to 1. So we're just equating coefficient, that's it. And you've got 2 variables, 2 equations. Can you solve for a? Yes, a and b. Yes, we can. So you do your simultaneous. What we can do here is we add them together. So a plus 2a, that is 3a, and then of course 5 plus 1 is 6. The b minus b cancels out. That is the purpose of simultaneous. Get rid of the one of the variable, solve for the other one. a equals to 2. If a equals to 2, what is b equals to? Well, a equals 2, so therefore b must be 3. 2 plus 3 is 5. And that's it, guys. You've got 2 and 3. Your partial fraction, coming back to this function right here, another way of writing 5x plus 1 over x minus 1 x plus 2 is 2. So a, you're subbing a back in here, 2 over x minus 1 plus b, which is 3, x plus 2 right there. Okay, so that's another way of writing 5x plus 1 over x minus 1 x plus 2. If you were to expand this again, like make them have the same common denominator, you'll get back to the 5x plus 1. And that's pretty much it for distinct linear factors. Yes, and if you guys are wondering that this might be long, there is actually a shortcut for this. I've made a video on it before, so you can check that out. I'll link it down in the description below, so make sure you check that out so that you can save some time in your SAC in your exam. So that's the shortcut for distinct linear factors. Now, this topic video though, we are going to move on to repeated linear factors and irreducible quadratic factors. So with repeated factors, the form is in this case, x minus 3 squared. So to recognize whether something is a repeated linear factor, you must have a linear factor, but then is repeated. So there's twice or 3 times or more. In special, most of the time you just get square and that's pretty much it. If you get cube, I guess the examiner is just being tough on you. But if you want to turn into partial fraction, what you can do is a over x minus 3. So it's a over just the linear factor without the repetition plus b over x minus 3 square. Okay, so that's how you convert this into partial fractions. So one of them without the square and the other one with the square. And of course, if it's a cube, then you put a plus c over x minus 3 cubed. So if this was a cube, you go to the power 1, to the power 2, and then to the power 3, and then a, b, c. And if there's more, you go d, e, and f, and then 4, 5, 6, and blah, blah, blah. Right, but in this case, we only want 2, so I'll just get rid of the c. How would we go about doing this? It's the same thing, guys. If you want to make this equals to 2x plus 3 over x minus 3 squared, you make the denominators the same as the one on the right hand side, and to do that you pick the missing one. So a, what am I missing? I'm missing an x minus 3, right? So you times it by x minus 3. What about b? B already has x minus 3 squared at the bottom, so you don't have to convert it. So that's it, b is just by itself, and of course that is equals to 2x plus 3. You can just ignore the denominator, they are the same, just to save some time. That's what you have, okay? That's your equation so that you can equate the coefficients. Ax minus 3a plus b equals to 2x plus 3. Now let's equate some coefficients. Ax is by itself, so therefore you can clearly see that a must be 2, right? There's only one x here, and that's the coefficient for that is a, and there's only one x here, the coefficient for that is 2, so therefore a equals to 2. And then on the right hand, and then the second and third terms, minus 3a plus b equals to 3. Well, we know a is 2, so negative 3 times 2 is negative 6, plus b equals to 3, so therefore b equals to 9 right there. So if you want to write this 2x plus 3 over x minus 3 squared into partial fractions, then you just sub back the 2 and the b, the a and the b back in here. So that is equals to a, 2 over x minus 3 plus b, which is 9 over the repeated one. So x minus 3 squared. So that's how you convert 2x plus 3 into partial fractions. So you split the 2x and the 3 apart. See, that's quite nice, okay? So that's the purpose of partial fraction. You're going to anti-diff this eventually. Moving on to the last one, irreducible quadratic factor. So what makes something an irreducible quadratic factor? Well, when you're doing partial fraction, you always see two terms, two factors. One of them though would be linear and the other one would be an irreducible factor. What do I mean by irreducible? That means you cannot convert this into any other linear factors. It's not possible. If you try trinomial method or quadratic formula or complete the square, you cannot turn this into linear factors. It can only stay as x squared plus x plus 1 and that's it, okay? You can't turn it into other linear factors. A way to easily identify whether a quadratic factor is an irreducible one is to find the discriminant. So discriminant in this case is b squared minus 4ac. What is b squared? B squared is 1 square, and then minus 4, a is 1, c is 1, so you multiply by 1, okay? and you get 1 minus 4, which is minus 3. If your discriminant is a negative number, then your quadratic factor is irreducible, so you can't do anything about it, okay? Right, so once you know that, yes, you've identified that this is an irreducible quadratic factor and the partial fraction involves that, you set up the equation. So over here for distinct linear factors a plus b, for repeated linear factors a plus b, on your denominator it's you've got the repeated and then you've got the linear, and then the last one for irreducible you have a over the linear factor a over x minus 1 plus, okay, this is a different part, bx plus c, everything over the irreducible factor, so x squared plus x plus 1. And yes, that's pretty much it, guys, how you convert this into the partial fraction. So in our example right here, we make that equals to 6 over x squared plus x plus 1. And then of course, I'll just move things over a little bit, x minus 1. We make them have the same common denominator, right? So if you want to solve for a, b, and c, then you make them have the same common denominator. In this case, what is a missing? A is missing the x squared plus x plus 1, right? So you multiply a by x squared plus x plus 1. And then of course, what is the bx plus c missing? So you compare its denominator to the original one. It's missing the x minus 1, right? The denominator is missing that. So you complete it and then you make it equals to 6. Ignore the denominator, they cancel out, that's fine. Let's solve for a and b. So expand this, ax squared plus ax. This is the longest one, but it's well worth it when you do answer the question. It's quite nice. Bx times x is bx squared. Bx times minus 1 is bx. And then c times x minus c equals to 6. Right, let's group them together. So ax squared and bx squared, a plus b, we're only looking at the coefficient. Do we have any x squared over here? No, there's none, so it's just 0. Now let's look at the other one, ax minus bx plus cx. Any x on the right hand side? Nope, there's none, so a minus b plus c, that is also equals to 0. And then on to the last one, a minus c, that is actually now equals to 6. So there is a number, a minus c equals to 6. And then once again, you've got how many variables? We've got 3 variables and 3 equations. Definitely can use simultaneous equation to solve for all 3 variables. So how would you go about this? All 3 equations have a, so a is common for all 3. So why not make b the subjects? Why not make a the independent variable? So in this case, b is equals to negative a, and for this one, c is equals to a minus 6, right? Now I'm going to try to solve for it. So chuck all this back into the second equation, okay? So now everything will be in terms of a. So if you rewrite the second equation in terms of a, that's a minus b. b is minus a, so that's a plus a. And then what is plus c? Well, we know that c is a minus 6, so it's a minus 6. I'm just chucking it inside, okay? Equals to 0. And of course, we have a, which is 3a. I move the negative 6 over, I get 6. And your final answer is a equals to 2. If you know that a equals to 2, what is b equals to? Well, b is equals to negative a, so that's negative 2. And then therefore c, a minus 6, a is 2. 2 minus 6 is negative 4. If you were to rewrite this partial fraction, it would be a, that is 2, over x minus 1, plus negative 2, that's b, x, make sure you put the x, and then minus c, plus c, but c is negative 4, and there we go, minus 2x minus 4 divided by the irreducible factor, and that's how you rewrite this original function right here, okay? So we get this part, and that's how you do all 3. Right, guys, we've just done distinct linear factors, repeated linear factors, and irreducible quadratic factor. This is all part of partial fraction. Hopefully you found this topic video useful. It's a good revision for year 11, and definitely you must know this for year 12. It is a vital component to integration, so make sure you know this. Make sure you rewatch this video if you're ever in doubt. But aside from that, guys, hopefully you found this video useful. If you did, leave a like, leave a comment. Thanks for watching, and I'll see you in the next video.